Hello everyone, we will continue with the powder coating technique for manufacturing textile prepreg. So, as I have mentioned already, powder coating is done using fluidized bed. So, in this method which has been discussed already, that the air is passed from plenum chamber through porous plate in a container where powders are present, powders of thermoplastic polymers are present, and once the air is passed through the porous plate, it forms basically cloud and there will be mechanical adhesion. So, this process has its own limitations because of mechanical adhesion, the powders may come out from the surface. So, in addition to this powder coating, the fluidized bed powder coating, there are couple of modification in this methods, this I will discuss. So, if we see the technique which we have discussed here, it is a fluidized powder bed. In this technique, there is a porous plate and over the porous plate the particles initially were present, particles of thermoplastic polymer like polypropylene particles, there are different particles are present. And below the chamber, below this particle container, there is a plenum chamber. In the plenum chamber, air enters, and when this air passes through the porous plate, enters through the porous plate, and this the particles actually it has been fluidized, this air fluidized the powder particle, and through this fluidized bed the reinforcing filament is passed, and the adhesion here is basically based on mechanical adhesion. There is no other force of adhesion. So, to have proper coating, so we have to immediately pass this coated filament through the heater, so that the thermoplastic particles melted and covered the reinforcing filament. Another development of this fluidized bed technique is electrostatic fluidized powder coating. In this method, air flows through the ionizing elements. So, this ionizing element is responsible for ionizing the air. So, this is normal air and when it is passing through the ionizing element, it becomes ionized. So, once the ionized air passed through the porous plate and this the fluidized bed here, the particles when its particles are fluidized and as these particles are fluidized and the air is also charged, these particles will also be charged with the same charge, and as these particles are charged, they will start repelling each other. And it forms a cloud, and another component which is the conductive component of fiber, that is the reinforcement component. Reinforcing component. This component, it has to be conductive in nature. So, this due to this conductive nature, this charged particle will get attracted on the surface of carbon fiber. Typically, carbon fibers are used here, or any other conductive fibers we can use. So, these fibers are, these particles are deposited on the surface of the reinforcing fiber, carbon fiber, and it is almost uniform, and after that, before the decay of the charge, this is passed through the heater, so that the thermoplastic components are melted and covered this reinforcing filament. So, looking at all these advantages, so this results much better covering as compared to fluidized powder bed. Another method, electrostatic spray coating, has been developed. Here the air is not being charged initially. The fluidized bed, here the air enters into the plenum chamber through the porous plate, it enters into the fluidized chamber, fluidizing chamber. So, this fluidized air is being pumped. Here we use air pump, it is being pumped to the electrostatic gun, where this air with particle enters through a Venturi system, and this is a electrostatic electrode it is ionized air through the gun, the air is being charged, and here mainly the cloud formations are there. As again the ionized air, it charged the particles repel each other and forms cloud and it is coated. Again here the reinforcing fiber, reinforcing filament, we need a conductive filament. If we do not use conductive filament, we have to make it conductive at least temporarily to have the proper coating. So, this charged cloud of powder, through this charged cloud of powder the reinforcing filament is passed and then it is covered with the particle, toe preg is formed, then it is passed through the oven where the particles melted and covered the filament. So, looking at all these three techniques, this electrostatic spray coating is the technique which has got is actually promising future to make the toe preg which is flexible in nature using powder coating. So, as I have already mentioned that electrostatic powder coating, here the electrostatic powder coating is similar to fluidized powder coating, except the fact that ionized air is passed through the porous plate, and dry electrostatic spray coating technique. So, that this challenges of thermoplastic composite that we have already mentioned, difficult to be incorporated into the fiber due to high melt viscosity. So, at the intersection of oven fabric and knitted fabric, in between yarn, in between loops. So, polymer degrade at high temperature, it is not normally dissolved because few solvents are they are not eco friendly, and due to that this entrapped air, the void content becomes very high. So, the solution is that pre-deposition of resin in the to form the toe preg. So, the resin is pre-deposited on the filament surface. So, toe is a collection of filaments and toe preg is a matrix coated collection of filament. The powder coating is important because complex shape cannot be formed from hot melt, solution impregnation and film stacking technique. Commingling, as I have mentioned, that it has got its problem of resin rich and resin starved areas. So, here the melt flow distance is reduced to a submicron level. So, in fact, there is no melt flow distance required. Here the flow of resin towards the length. So, along the length, not across the length. Here we do not use any binder, solvents or water. So, these are the two techniques we have used, discussed: fluidized bed, electrostatic fluidized bed, aquatic aerosolization and deposition is also there, recirculation powder deposition, moisture assisted deposition, liquid phase deposition. These are the powder deposition techniques and electrostatic spray coating. So, now I will discuss the electrostatic spray coating, which has already been discussed little bit. Here I will discuss the development of this technique. The powder which is used, it is cryogenically grounded powder, fine powder of polypropylene. If we see the flow chart for this method, that is electrostatic powder coating process, here carbon tow is used, that is multifilament carbon. Now, fluidized hopper, okay, conveying and dosing air supply. So, then after that the electrostatic spray gun. So, this electrostatic spray gun, it charges the particles which is coming from the fluidizing hopper and forms cloud here in this zone, and this carbon tow is covered with the polypropylene powder. So, polypropylene powder is coated with the carbon tow, it is coated carbon tow, and after that it is passed through the hot air oven which forms the toe preg. This toe preg is very flexible in nature and we can form the woven fabric or any other textile structure out of that. Now, if you see the schematic diagram here, this is the toe, it is a carbon toe in our case, and here this is the air inlet plenum chamber as I have mentioned here, and this is fluidizing bed, and this is the venturi. So, here the conveying air inlet is there at high pressure. This venturi and air pressure, it helps the particles to pass through this path and enters into the electrostatic spray gun, where the particles are being charged and these charged particles are deposited on the surface of the filament, carbon filament, and immediately after that it is passed through the hot air oven. So, partially fused toe preg are then wound on a package. So, this is used for making the preform. This is the chamber, powder coating setup here, powder feed hopper, this is the powder feed hopper. So, conveying air is there, fluidizing air at this is the fluidizing air and this is the dosing air. If you see, this is the venturi, it has got its, so here this is the fluidizing bed, porous plate, and here it is a plenum chamber, and this powder is being conveyed and to the, it is going to the spray gun. This is a venturi pump conveying air pressure. So, this is the pressure range 0 to 5 bar, dosing pressure, and it is going ultimately to spray gun. It has got 4 sources. This is coming from the this fluidizing chamber, and here it is a electrostatic spray gun where the particles are being charged. So, in this at the tip of the electrode, it is actually, it creates 30 to 100 kilovolt charge is created. Depending on this charge, the particles are being charged and clouds are formed. This is the internal structure of the spray gun and the convective oven. So, here maximum heater temperature is 300 degrees Celsius. The dimensions are given here, length is 1 meter, width 0.5 meter and depth 0.45 meter. This is the dimension. So, when the coated filament passes through this chamber, so powders are melted. Here is a take up assembly, the parallel winding. So, powder recovery, air dryer is important because compressed air is used for fluidizing bed and conveying the air with proper particle to the tow, which is important. The compressed air used should be free from moisture, oil and contaminant. So, if moisture is there in the air, then that will actually reduce the efficiency of charging or powder agglomeration may be there. So, we need properly dry air. So, this is the total fiber powder coating setup. Let us see the running of the instrument. Here this is the carbon toe. So, the let-off arrangement is there, it's, and here it is moving here. This is the coating chamber. Now, this is entering to the coating chamber, where you can see this is the spray gun. Now, at the you can see clearly the cloud is being formed and the powder, it is coated by the powder. Filament is coated by the powder, and immediately after that it will pass through the heater, where this will be melted. Okay. This is the heater chamber. So, ultimately we will form the tow preg, and what has been observed, this tow preg by this powder coating technology, it is very flexible. Now, in the next class we will discuss another technique of composite manufacturing. It is a thermally bonded roving structure, which is actually the natural fiber, how from the natural fiber we can develop unidirectional composite. So, this technique I will discuss in next class. Till then, thank you.